Good day everyone, welcome to JD's channel. Today, we're going to discuss another topic. Don't forget to like, share, and subscribe for more tutorials. Thank you and God bless. Okay, hello again class. Uh, our topic for today is all about stress strain diagram. Okay, so ayan. So let's get started. So ano ba yung mga content natin class? Ayan, so okay. First is yung what is stress strain diagram. Secondly, class, we have this tensile strength test. And yung pangatlo is stress strain diagram. So yung kanyang mga illustration and the discussion, ano po. So nandiyan dyan. And yung mga points po natin sa stress strain diagram. Yan po yung apat na ating itatakal ngayong sa pag-aaral natin. Okay, so and don't forget to like, share, and subscribe to this channel na po for more tutorials. Okay? So, okay, tayo po ay mag-start na. So for introduction class, you may have noticed that certain object can stretch easily, but stretching object like an iron rod sound impossible. So, tama naman po diga. So, kung yan ay rubber band, so siguro it is easy to stretch, but when we say it is an iron rod, okay, then you gonna stretch it is so sounds impossible. So now we will study why a few objects are more malleable than others. So mainly we will discussing stress strain curve because they are useful in understanding the tensile strength of a given material. So again, what is stress strain diagram? Is a stress strain diagram or stress strain curve is used to illustrate the relationship between a material's strength or stress and strain. A stress strain diagram is a stress strain curve that can be constructed from data obtained in any mechanical test where load is applied to a material and the continuous measurement of stress and strain are made simultaneously. Another one here is what is stress strain diagram is a stress strain curve or a diagram is visually display the material's deformation in response to a tensile, compressive, or torsional load. So that is our stress strain diagram. And also, depending on the material being tested, a stress strain curve or a diagram can indicate key properties of material, including its proportional limit. So we have the elastic region, the plastic region, and also the yield point, the ultimate strength, tensile strength, and lastly, the ruptured strength. Okay, so those are the points, or what we call is key properties of a material. Okay, so let's proceed, class, to the next. So another topic here is what is tensile strength test? Okay, so we define first the stress strain diagram. Now we proceed to tensile strength test. A tensile test, or also known as tension test, is one of the most fundamental and common type of mechanical testing. A tensile test applies tensile or pulling force to a material and measure the specimen's purpose to the stress. So that is that is the tensile strength test. So by doing this, tensile test determine how strong a material is and how much it elongates. So that is the purpose. So how strong a material is and how can it elongate. And tensile tests are typically conducted on mechanical instruments. So ito po yung sample ng isang mechanical instrument na ginagamit sa ating tensile strength test. So ito po, ang tensile strength test is it measure how strong material is at para ito yung makatulong din sa bawat manufacturing company if they to determine if yung material na or the finished product is of good quality. Ayan. So, ito po yung mga machine na ginagamit. Ano po? So, kung mapapansin nyo, meron tayong nilalagay na specimen sa gitna. Ano po? And then, babatakin siya. Magkakaroon ng, there is a tensile force. Okay? From the upper and the lower part where they gonna pull the specimen up to the breaking part, or the breaking point. Yeah. And then all the data will be distributed to the computer and will display stress strain diagram. So this is the setup class. So here we put the specimen here, and then this mechanism will gonna pull the specimen up to the breaking point, and all the details and all the data that that is harness, or all the result will be transfer or transmit to the computer, and it will result in a stress strain diagram. Okay, so for us to get closer, so the setup, okay, this setup is this part. So we just close this part, we just close up this part, so it looks like this. Yeah. Okay, so here class is our grips that hold the specimen firmly. So ito yung ating specimen class. Ilalagay lang siya doon, and then iipitin siya ng napakaigpit. And then there is a constant rate motion where in yung force natin dito, tensile force and tensile sa baba, babatakin siya sa pataas up to na siya ay maputol. Okay? And all the data nga na magagather dito is yun, mag-result sa tensile strength, magre-result sa stress strain diagram. Okay, so ayan, so ito na class yung ating stress strain diagram. Ano po? Ayan, so this is a stress strain diagram where the y-axis is the stress and the x-axis is the strain, and we have these points. Okay, so we will discuss these points. Okay, so maya na content. So this stress strain diagram is for structural steel only. So class, remember na kada material, iba-iba siya ng property, iba-iba siya ng behavior, at meaning to say, iba-iba din po siya ng stress strain diagram. Ano po? So maaaring iba sobrang taas sa proportional pa lang. Maaaring ba yung maliit, mababa, or maaaring iba yung ganito lang din. So, depende po sa klase ng ating material yung ating magiging result. Okay? So, but for our illustration, since this stress strain diagram for structural steel is the most common stress strain diagram, so this is the diagram that we are going to discuss. Okay? So, let's discuss first the first point, which is the proportional limit. So from this class, from the origin or the zero up to the proportional limit, we can notice that there is a proportionality between the stress and the strain. So whenever the stress is increases or the load is increases, so since force P is equals or directly proportional to the stress based on the formula, stress is equals to force over the area, force P over area. And then pag liit naman ng ating area, so the stress will also increases. Okay, so here increasing in stress is also increasing in strain. Okay, so class na nangyari, meron siyang linear relationship. Okay, so pag sinabi natin linear relationship, yan, i-grade siya ng linya or line because of the relationship between the stress and the strain. So while the load is continue, or if we add, or if the load is increasing, the stress is increasing also, and the strain. But after that stage, or let's say there is a point wherein their lifespan or the life of our material, that there is a proportional limit. So what do you mean by proportional limit? Proportional limit classes, beyond this point, there is the relationship of stress strain diagram is not proportional. Not the proportionality of stress and strain and beyond this part. Okay, so that is what we call proportional limit. From the word itself, the proportionality or the proportionality of stress strain ends beyond here. Okay, so there is a limit or proportionality of a material. Okay, so and then this proportional limit is what we also call the Hooke's law. Okay, so there's another video that discussing Hooke's law or the proportional limit. Ayan, so and yung ating pag-aaralan nga is dito tayo nakabase, since ang ating goal is or ang ating studies with the effects of stress to the strain, so the relationship of stress to the strain. So kaya hanggang dito yung ating pag-aaral. So dito nakafocus. Okay, so sa method sabi about the proportional limits, yun yung ating focus. So all about proportional limit. Okay, class. So that is the first stage or the proportional limit. Ano po? So again, for proportional limit, from the origin to this point, stress strain curve is a straight line, or they have the linear relationship. It is the region in the stress strain curve that obeys Hooke's law. So again, sabi ko nga sa inyo, yan. So kasi may ating proportional limit. So it also called Hooke's law, since Sir Robert Hooke is the one that first observed this property, or this relationship between the stress strain curve. Okay, stress strain. In this limit, the ratio of stress with strain give us proportionality constant known as Young's modulus. Or the symbol for here is letter capital E, or Young's modulus, or modulus of elasticity. Okay, so the next one is the elastic limit. Okay, so this is the next point after this proportional limit. So okay, from the word is elastic limit. So there is, beyond this point, there is NDR, elasticity of a material ends. Okay, beyond this part. Okay, so for easy illustration or understanding, let's take this example. So uh, for instance, or let's say that you are holding rubber band and then you pull it. Okay, so with and then you remove your hand on that rubber band. So what you have noticed? Okay, so okay, awesome. So that is right. Okay, so the rubber band come back to its original shape, okay, or original length. So so that is elasticity. That is elasticity of material. It is able to go back to its original shape, length, or volume, or area. Okay, so and then what if I told you that if you okay, let's say there is a in this elastic limit, also beyond this elastic limit, there is a permanent deformation of this body. Okay, so let's say you have the rubber band, okay, the same rubber band, and then you pull the rubber band, which is you pull the rubber band in a way that it is greater. So there is a greater force that you exert. Okay, unlike the first one that you stretch it, that uh, it came back to its original area or original shape or length. This time around, you pull it in a greater force, but don't let it split. Okay, so what have you noticed? So that's right. Okay, so uh, the rubber band changes its shape or changes its length. So there is a lengthen of the length. Okay, so there's change in shape, change in length. Okay, so that means to say, or therefore, we therefore conclude, class, that uh, this material attain its elastic limit, and as a result, or beyond this elastic limit that a material has, is what we call a permanent deformation. So in this part, okay, there is beyond this part there is a permanent deformation of a body. Okay, so elastic body beyond this point or point beyond which permanent deformation occurs. It is the point in the graph up to which the material returns to its original position when the load acting on it is completely removed. So katulad ng ginawa natin kanina. So beyond this point, the material does return to its original position and plastic deformation start to appear in it. So that is our elastic limit. So the next one is, okay, so the yield point. So here in the yield point, okay, so what have you noticed from this point up to the ultimate strength? So in this point class, even if you do not exert or you do not add additional force to the body, it is still developed or it increases in deformation, or it increase in deformation, or it increase in the strain. So by this time uh, the the stress strain diagram is going to have a horizontal, okay, horizontal curve. Okay, so I mean to say the interpretation class is the load or the stress is stay the same, but the strain increases. Okay, so that is the interpretation. Okay, so by definition, the point beyond which increase in strain without increase in applied load. All right. So the yield point is defined as the point at which the material start to deform plastically. Yeah. So in the first two, so the proportion and elastic, there is a elastic deformation. Okay, and from yield point up to the ultimate stress and the rupture distress, there is a plastical depth or they deform plastically. After the yield point is passed, permanent plastic deformation occur. There are two yield points, so that is the upper and lower yield point. Pero hindi po tayo dyan mag-focus class. Ano po? So, hindi tayo mag-focus sa next natin na point, which is ayan, yung ating ultimate strength. So from yield point up to the ultimate strength. So what is the ultimate strength? So as you can see, it is the highest, okay, in this curve, okay. So meaning say it is the highest force that a material can carry, okay. So that is the ultimate strength. From the word is the ultimate strength that a body can carry, that a body has. This is the point wherein the body has its maximum force to carry. Okay, so highest ordinate on the stress strain curve. So since the ordinate is in the force or in the stress, so means say the highest stress or force that on a stress strain curve. So yun yung ating ultimate strength. It is the point that represents the maximum stress that a material can endure before failure. Yan. So beyond this point, failure occurs. Okay, so this is the maximum and the maximum stress that a material can endure. Pag siya magkaroon ng failure or magkaroon ng fracture. Okay, so the last two. So here class we have two event here. So it can be So under the ruptured strength, we have the nominal and the true. So for nominal, so the nominal is this part, okay? This part is if the material in this part have already the fractured. So naputol na siya. Okay, so parang ito, yan. Ito yung original, okay, class. So under ng tensile force, given na increasing yung kanyang tensile force, so nagkaka siya ng fracture sa gitna. Okay? Eh, how about sir with this part? So dito ngayon class, ito yung sinasabi ng true ruptured strength. So ano bang mapapansin niyo dyan? So napansin natin dito class na pataas siya, di ba? So minsan tumaas yung stress. Okay, so by definition, so yung ating stress at failure is what we call nominal. Consider necking gives true ruptured strength. Okay, so nominal stress developed in a material at ruptured. It is not necessarily equal to the ultimate strength. So this is the point in the stress strain curve at which the failure of the material takes place, or here is the breaking region. Yeah. So okay, so again, ruptured strength or true ruptured strength. Let's consider this illustration. So first we have this body which is under the tensile force P, and then due to this continuous tensile stress in the body, so the body create necking. So this class is what we call necking. So as you can see, the area in this part on this necking is smaller than this original. So we need to say class, the stress here is greater than the other two, because since stress is equals to force over the area, so we have the inverse relationship with the area and the stress. Okay, so this is the actual. So as you can see, this is good, and the necking is starting here, and yun, meron na necking. Okay, so sabihin lang nito, if nagkaroon ng necking and then lumit yung area niya, it experiences high stress kumpara dun sa iba, and that result to fracture. Okay, so ayan, so unlike the nominal, it already fractured, but in true fracture strength, there is a possible increase in stress in the smaller area. Thus, it will result to failure after some time or after weeks. Okay, so again, what is stress, or what is stress strain diagram? So stress strain diagram is from the zero up to the proportional and the yield or the elastic limit. Okay, so we're in under siya ng Hooke's law, or siya ay elastic region, and beyond this is what we call the plastic region, wherein involved yung ating yield point, yung ating ultimate strength, yung ating ruptured strength, and yung ating breaking, or what we call the nominal. Okay, so nominal. Okay, class. So that would be all for this discussion. I hope that you learned something from our discussion. Okay, so don't forget to like, share, and subscribe to this channel for more tutorials. Again, thank you, class, and God bless. To God be all the glory. See you sa next tutorial.